Good day everyone. So welcome to our video lesson for General Chemistry 1 Module 2, and we are going to talk about isotopes and chemical formulas. So for this module, we are going to divide our video lesson into two parts. The first one is for the first three learning competencies which we were able to cover in our Google Meet class last time. And the second part of the video will cover the last learning competency, which is calculate the empirical formula from the percent composition of a compound. Para yung mga naka-attend na ng klase sa Google Meet nung nakaraan, ito lang i-access nila. Pero for those who were not able to attend the previous online class, they will have to view both videos or both video lessons. So the first video lesson will cover the first three learning competencies. The first one is recognize common isotopes and their uses. The second learning competency is represent compounds using chemical formulas, structural formulas, and models. And the third learning competency for the first video is name compounds given their formula and write formula given the name of the compound. Okay, so again, yung sa video na to, we are just going to cover the first three learning competency. And for the last video, separate video na yun para mas madaling ma-access ng mga naka-attend na no first nung online class natin nung nakaraan. Okay, so first, let us define what is an isotope. So, na-cover na natin ito sa pre-learning homework. I hope you are already familiar with the definition of isotope. So, an isotope refers to atoms of the same element that contain an identical number of protons but a different number of neutrons. So, again, similar atoms lang ito. For example, hydrogen. Lahat ito hydrogen ang tinutukoy ng isotope. But the difference with these atoms is that they have different numbers of neutrons. Therefore, since they have different number of neutrons, then they have different mass numbers. So para mas malinaw, let's have some examples. Pero before that, review muna natin again yung mga parts. Baka nakalimutan na ninyo. So again, these are the parts of the atom. So we have the central part of the atom, we call the nucleus. Inside the nucleus, we have the protons, yung kulay pula. Okay, and the neutrons, yung kulay green. So the neutron is the one that is responsible for the total mass of the atom. Napakaliit lang yan. Sobrang liit lang yan. Pero siya ang responsible sa bigat ng buong atom. Okay? While outside the nucleus or moving around the nucleus are the electrons. And electrons' mass are very, very small, considered to be negligible compared to the mass of one proton. Kahit na 100 o 1,000 electrons pa yan, kulang pa yon para tumapat sa timbang ng isang proton o kaya sa isang neutron. So therefore, the mass of the electron is negligible, and the total mass of the atom is only dependent on the number of protons and neutrons inside the nucleus of an atom. Okay, so we have these are examples of isotopes. So these are the isotopes of hydrogen. So we have three isotopes. We have hydrogen 1, hydrogen 2, and hydrogen 3. So as you can see, these isotopes all contain the same number of protons. Tig-iisa lang sila ng proton. Okay, kasi the moment na madagdagan yan ng another proton, hindi na yun hydrogen. Okay, pag dalawa na yung proton, let's say may proton pa tayong isa dito, hindi na yun hydrogen kundi helium na. Okay, so the identity of an atom is actually dependent on the number of protons, or what we call as the atomic number. Okay, now let's have the pen. Okay, so again, these are the three isotopes of hydrogen. Hydrogen 1, okay, because its mass number is 1. Hydrogen 2, because its mass number is 2 because of the two nuclear particles. We have protons and neutrons, dalawa sila. Dito, kaya siya, ang mass number niya ay 1 kasi isa lang yung nasa nucleus niya. Okay, dito dalawa, kaya mass number niya ay 2. While for hydrogen 3, so 1 proton but it has 2 neutrons. So therefore, its mass number is 3. So by the way, they have special names. Hydrogen 1 is called protium. Hydrogen 2 is called deuterium, while hydrogen 3 is called tritium. Okay, so tandaan nyo na lang yung mga special names yan because in some applications, particularly nuclear applications, you can hear a lot about deuterium, particularly deuterium and tritium. Madalas ko yung makakarinig tungkol sa mga nuclear applications nila. Okay, so that's so these are examples of isotopes. So they are all hydrogen atoms, but they have different masses because they have different numbers of neutrons. Okay, so yun yung tinatawag natin na isotopes. Okay, now one particular use of isotopes is or one particular characteristic of isotopes that are of use in medicine and in industries is its radioactivity. So yung mga isotopes na radioactive, meron silang mga kakaibang properties na ginagamit at dahil doon ginagamit sila sa mga sa ilang mga industrial applications um, and medical applications. Okay? So meron ding mga hindi radioactive na mga isotopes which is yung palagi natin na-encounter sa paligid natin. Pero yung mga isotopes na radioactive, sila yung may mga special use. Okay? So ano bang katangian ng mga radioactive isotopes? So radioactive isotopes are quite unstable because their nucleus is heavy. Okay? Because of the extra number of neutrons, or kung napakakonti naman ng neutrons, ayun, nagkakos siya ng instability sa nucleus ng atom. And because of this instability, sometimes, or yung mga isotopes na to, yung nucleus nila, nagbe-break ito to produce mga mas maliliit pa na particles and energy. Okay? Yung mga pinapakawalan niya ng mga maliliit pa na particles, pwedeng electron, positron, or neutrino. Ayan. At yung energy, yan yung may mga special use sa mga fields like special industries and medicine. Okay. So here are some radioactive isotopes that are of use in the medicinal field. So example is cobalt-60. This is the most frequently used isotope in medical applications, particularly in cancer prevention or cancer therapy. So it is used for radiation therapy to prevent cancer. So yung cobalt-60 kasi nag-emit ng radiation at yan yung ginagamit ng mga devices sa mga hospitals to target cancer cells. Yung energy na pinapakawalan ng cobalt-60 radiation na yun yung pumapatay sa mga cancer cells. Tawag natin doon ay radiation therapy. Another one is iodine-131. It is used to locate brain tumors, monitor cardiac, liver, and thyroid activity. Okay? So, para malaman kung maayos pa ba yung functioning ng mga internal organs natin na yan. So, ginagamit ang iodine-131 to determine the activity of these internal organs. Another one is carbon-14, used to study metabolism changes for patients with diabetes, gout, and anemia. Okay? So, ganito yan. Paano ba, halimbawa yung locate, ayan, locate yung thyroid activity or brain tumors, monitor cardiac, liver, and thyroid activity. Tapos, eto, metabolism changes for patients with these diseases. Paano nangyayari yun? So, it's either the patients are injected or pinapakain sila ng mga safe naman na substances na radioactive. Nag-i-emit sila ng napakakonti lang naman na amount ng radiation. And these radiations are then detected by machines. So, pag na-detect na yan ng mga machines, yung machine na magsasabi o magpapakita sa atin ng mga images to indicate whether there is a normal or abnormal changes or activity inside our bodies. Okay? So, another example is carbon-11. Okay? So, carbon-11, this is napapansin ninyo, may dalawa na kagad tayong isotopes ng carbon na ginagamit. Actually, ano yan, meron tayong carbon-11, carbon-12. Carbon-12 is the most common isotopes of carbon. Uh, yung katawan natin, majority ng isotope ng carbon is carbon-12. Yun yung nasa katawan natin. But we also have carbon-14 and other isotopes. Pero napakakonti lang yan. Okay? So carbon-11 is tagged onto glucose to monitor organs during a PET scan or PET scan. When we say PET scan, yan yung tinatawag natin na positron emission tomography. Okay? So, paano nag-work yan? So, hindi ko pa masyadong ano talaga yan eh. Pero, ang nangyayari, it's either ingested or ini-inject din sa bloodstream natin. Yung glucose na, yung mga carbons ng glucose na to ay merong carbon-11. So, kakalat yan sa buong katawan natin. And, this carbon-11 will produce positron. Yung positron yan yung kumbaga parang kabaliktaran ng electron. Kasing bigat lang ng electron pero instead of negatively charged katulad ng electron, it's positively charged. So it will emit certain amount of energy and that energy will be detected by the machine and will give us an image of our whole body. Okay? So, yun yung nangyayari sa PET scan or PET scan, positron emission tomography. Yan yung mga nakikita natin minsan sa mga movies o kaya sa mga uh, mga medicine videos na parang ini-scan ng layer by layer yung mga parts ng katawan natin. So, again, that's positron emission tomography. Okay? So, another is sodium-24. Used to study blood circulation. Another one is thallium-201, determine damage in heart tissue and in detection of tumors. And lastly is technetium-99m. Just like iodine-131, it is used to locate brain tumors and damage to heart cells. Radio tracer in medical diagnostics, imaging of organs, and blood flow studies. So actually, itong tatlong to, ito yung madalas ko talagang naririnig na ginagamit sa application ng medicine. Cobalt-60, iodine-131, and technetium-99m. Okay? Yan yung mga pinakamadalas kong naririnig for radioisotopes used in the medical field. Okay, sa industrial applications naman tayo, we have americium-241 used to detect uniform thickness when rolling steel and paper. So, bakit na-maintain? Kung papansinin niyo yung mga papel natin, mga pad papers natin, mga notebooks natin, pare-pareho lang talaga sila ng kapal o ng nibis. So, paano yun na-detect na machine na tama lang yung nagagawa ng machine na kapal ng papel o kaya let's say steel dito sa case naman na to. So, gumagamit ng mga radioactive isotopes yung mga machines na yan. Okay? So, once na nag-error, mag-stop yung production tapos yun, i-calibrate ulit yan ng mga engineers and so on o mga technician para ma-maintain yung quality ng kapal ng papel o kaya ng steel na napoproduce ng mga makina. And it is also used to determine location of oil wells. Okay? Sodium-24 uli, it is also used in oil well studies and to locate leaks in pipelines. So imagine mo, mga mahabang pipes na nagko-contain ng mga natural gas at saka ng mga liquid fuels. Once na magkaroon ng leaks yan o kaya ng mga cracks, potential na magkaroon ng disastrous accidents, mga massive explosions. Okay, so to prevent that, yung mga scientists, yung mga nuclear scientists, they use sodium-24 and other radioactive isotopes to detect leaks or mga cracks, mga possible cracks sa mga pipelines. Pwede rin sa mga boilers and aircraft parts, pero ang ginagamit naman nila dito ay iridium 192. Okay? Especially sa mga aircrafts. Ayan. Ginagamit yan sa sa radio photography. So halimbawa pinicture mo yung isang part ng ng aircraft, makikita ka agad dun sa 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 machine na ginagamit na sa machine o sa radio photography kung merong mga maliit na cracks. Sa visible eye, no, maaring hindi mo siya napapansin. Pero using radio photography, they can see even the smallest cracks. Okay, o kaya mga potential na na maaari magkaroon na ng damage as let's say pag nag-continue ng paggamit yung parts na yon, so pwedeng masira na kagad. Magde-detect yun using radio photography and they use radioisotopes like iridium-192. Okay, isa sa mga pinakagamit na gamit din sa industrial applications, particularly sa nuclear power plants, ay ang uranium-235. Okay? Maraming isotopes din ang uranium-235. Meron pa nga yung uranium-238. Pero ito yung yung naturally, alam ko, naturally occurring na radioisotope ng uranium. Ito yung enriched. Yung uranium-235 na yan, this is the enriched uranium. Okay? So, yan yung magandang gamitin for nuclear power plants and naval propulsion fuel systems for mga submarines. Okay? And production of fluorescent glassware and colored wall tiles. Pwede rin gamitin yung mga yan sa mga atomic bombs. Pero syempre, hindi natin masyadong didiscuss yun kasi masyadong negative. Ang nuclear science ay marami namang mga positive na gamit. Katulad ng nuclear power plants na napaka-safe at napakalakas ng energy na kayang i-produce. Just imagine, yung isang pellet ng uranium-235 na kasing laki lang ng eraser ng pencil, yung energy na kaya i-produce nun ay katumbas na ng ilang daang drum ng oil. Just imagine, isang napakaliit na pellet ng uranium-235 kasing size ng eraser ng pencil, ang katumbas nun ay ilang daang drum ng oil. Or, ilang tonelada o gabundok na coal. Just imagine, kung susunugin mo yung gabundok na oil, ilang daang drum ng oil, at gabundok na coal, napakaraming pollutants dun sa hangin. Masama talaga sa kapaligiran. Okay? Pero, sa uranium-235, wala ni isang pollution ang ilalabas noon. At napakaliit lang niya, kasize nga lang ng eraser ng isang pencil. Okay? So, napakagandang source of energy ang nuclear energy, particularly itong ginagamit kadalasan, uranium-235. Okay, last one is californium-252. It is used to determine moisture content of soil, important for road construction and building in the streets. So, halimbawa, no, ganito, kung ikaw ay isang civil engineer, gusto mong malaman kung pwede na bang padaanan sa mga sasakyan, yung kalsada na ginawa mo, o kaya yung building na ba ito na ginagawa mo, pwede na bang patayuan ng another floor? Okay, tuyong-tuyo na ba yung semento na binuhos ninyo dun sa layer na yon, sa floor na yon? So you can use a device that uses californium-252 to detect the moisture content. Kung mataas pa yung moisture content, syempre hindi ka pa pwedeng magpatong ng another layer, delikado, baka masira pa. Okay, o kaya yung kalsada, pag pinadaanan mo kagad yung kalsada, tapos basa pa yung ilalim, hindi pa talaga tuyong-tuyo yung semento sa ilalim, then magkakarak din kagad yung semento, sira rin kagad yun. So, ayan, radioisotope ang ginagamit natin, particularly californium-252 to detect moisture content for soil and road construction for cement. Ito pa, pwede rin yung gamitin yung radioactive isotopes for research applications. Halimbawa, Carbon-14, it is used for carbon dating to identify or determine the age of certain artifacts. Like for example, yung mga labi ng mga sinaunang tao, paano nila nalaman na ilang libong taon na mula nung namatay yon? O kaya halimbawa yung mga artifacts, mga tela, mga upuan. Okay? Paano nila nalaman na sa ganitong panahon ito ginawa? Halimbawa, panahon ng mga ng mga Egyptians. Paano nila nalaman na ilang libong taon na nakakaraan mula nung namatay yung mga labi na yun o kaya yung mga artifacts na nakuha nila mula sa pyramid. So, they use carbon dating. Okay? So, yun. Another is phosphorus 32 and phosphorus 33 used in research involving biology and genetics. Okay? Parang ano yata ito para sa phosphorescence. Okay? Hindi ko lang alam kasi biology, hindi ko masyadong alam yung particular application yan. Selenium 75 used for protein studies in life science. Strontium 85 used to study metabolism and bone formation studies. And hydrogen 3 or tritium used to study life science and drug metabolism. So those are examples of isotopes or particularly radioisotopes that are used in different fields. So that's for the first learning competency, to recognize common isotopes and their uses. Now let's move on to the second learning competency, to represent compounds using chemical formulas, structural formulas, and models. So let us first define what chemical formulas are. So the first, our definition is, a chemical formula is an expression showing the chemical composition of a compound in terms of the symbols of the atoms and of the elements involved. Okay, while structural formula is a graphic representation of the molecular structure showing how the atoms are possibly arranged in the real three-dimensional space. Pero not necessarily na three-dimensional, pwedeng two-dimensional space lang. Kasi sa three-dimensional, may iba na tayong ginagamit yan, which is yung model. Okay, mamaya papakita ko sa inyo yung ball and stick model. Okay, so let's have some examples. So this is an example of a structural formula. So it shows how atoms are arranged in space. Paano din sila nakakonekta dun sa iba pang mga atoms. Okay, so this is a structural formula. While the chemical formula for this structure is this. So sinisimplify na agad natin. Hindi na natin ini-include yung mga bonds. Yung mga single bond at saka yung mga double bonds. Hindi na kasama yan. Okay? Ang pinapakita lang natin for chemical formula is the number of atoms present in the compound. So like for example, in this case, for ethanol or ethanaldehyde, we have 2 carbons. So 1, 2, kaya C2. Yung number of atoms is represented by a subscript. Okay, so dalawang carbon. We have 4 hydrogen atoms. 1, 2, 3, 4. Kaya H4 and O, nag-iisa lang. So, automatic may 1 yan. Parang katulad sa algebra. Pero hindi na natin sinusulat. Okay? So, that's the difference between structural formula and chemical formula. So, chemical formula, you just write the symbol of the element and the number of atoms present in the formula, in the structural formula. While for structural formula, you show the arrangement of the atoms, how they are connected to each other, and the number of bonds. Papakita rin kung single bond or double bond or pwede rin may triple bond. Okay? Now, how about for a model? One of the models that we use to represent atoms or molecules is the ball and stick model. So this is the ball and stick model for ethanol. So, ito, 3-dimensional na siya. Dito kasi pinapakita, parang flat lang yung molecule natin. Pero in actuality, hindi naman talaga. Okay? They are arranged in 3-dimensional arrangement like this. Okay? So, nakaganyan sila para maiwasan yung pagsisiksikan ng mga atoms and to prevent repulsion between the atoms and their bonds. Okay? So, pag magsiksikan yan, ano, magiging unstable yung atom natin. Okay? So, yun yung purpose naman ng models, particularly the ball and stick model, to show us that three-dimensional arrangement of the atoms in a compound. Okay? Another one, let's have structural formula for this compound. Okay? Ayan. So, this is dihydrogen sulfate. Pag hinalo mo yan sa tubig, yan yung nagiging sulfuric acid. Okay, so how do we write this in chemical formula? Ganyan ang pagkakasulat niya. Pwede bang magkakarambol yan? Minsan nag-iiba yung arrangement yan eh. Pero pag sinusulat natin siya, normally ganito talaga yung ayos. Bakit? Kasi itong SO4, this is actually a polyatomic ion. This is sulfate. Okay? So, kaya ganyan ang pagkakasulat sa kanya para mas madali natin siya makilala as sulfate. Kapag hindi ba kasi natin, ginawa natin O4S, magugulo na. Kunwari ganyan. Baka magulo tayo, hindi kagad natin siya ma-identify as a sulfate. Mahirapan tayong magpangalan. Kaya, ganito lang talaga yung pagkakaayos sa kanya. Nakagrupo kasi sila yan. Ito yan yung SO4. Yan. Yan yung sulfate natin. Okay, sulfate. And then, meron tayong dalawang hydrogen attached to the sulfate. Isa, dalawa. Okay? Tsaka isa pa nga pala, bakit ganito yung pagkakaayos sa chemical formula natin? Bakit hindi natin sila normally pinapag-rumble? Kasi generally speaking, atoms are arranged in a chemical compound like this. Nauuna yung positive, followed by the negative. So this is positively charged, while sulfate ion is negatively charged. Okay? Kaya siya yung nandito sa right side, yung nasa left side, itong hydrogen, kasi siya yung positively charged. So again, this is dihydrogen sulfate. Pag hinalo mo sa tubig, it becomes sulfuric acid. Okay, let's have another example. By the way, the ball and stick model for sulfate is this. Ayan. Hindi yan flat. So, three-dimensional din. Ito ay parang nasa left and right natin. Ito ay nasa harap. Nakapunta sa harap. Ito naman ay bandang likuran. Okay? So, ganun yung arrangement for the ball and stick model for dihydrogen sulfate. Another one, let's have this N tapos tatlong H. O, ganun lang kasimple. It's NH3. This is ammonia. Okay? So, hindi na natin ina-identify o ini-include sa chemical formula yung mga bonds. Yung mga bonds na yan. Pati yung lone pair, hindi na yan included. Okay? Ang ginagawa lang natin sa chemical formula, we just write the name of the, or the symbol of the element, plus the number of the atoms. Okay, so, ball and stick model for ammonia is this. So, yung mga bonds, yan, pinapakita pa rin sa ball and stick model. Pero itong mga lone pair na ito, again, para sa mga medyo nakakalimot na, we call this as the lone pair. Hindi na natin pinapakita yan sa ball and stick model. Because, again, these are just electrons. Napakaliliit din yan. Almost negligible. Okay? Pero parang naandyan siya naglalay somewhere dito sa area na to. And actually, that lone pair, kahit na hindi siya pinapakita sa ball and stick model, that lone pair is actually responsible for the bending of the bonds between nitrogen and hydrogen. So, siya yung reason bakit nakapush pababa. Okay? Yung tatlong bonds na yan. Bakit hindi na lang mag-flat yan? Pwede naman na mag-flat yan eh. Pero dahil may presence tayo ng lone pair dito, okay? Ayun. Nagbaba yung tatlong bonds between nitrogen and yung tatlong hydrogen. Okay. So, for this one, eto. This is caffeine. Oh. A challenge. Pwede nyo i-post tong video and then, kayo naman ang gumawa ng chemical formula for caffeine. Again, you just write the symbol of the elements and then identify the number of atoms of that element in this compound, okay, by writing it in subscript, tapos kumpletuhin ninyo to make the chemical formula for caffeine. So, pause nyo muna itong video para bago kayo para magkaroon kayo ng time para gawin yung chemical formula. Okay? So, i-move ko na yung slide natin. Once you are done, okay, the correct answer or the chemical formula for caffeine is this. C8H10N4O2. O, tingnan natin. We have 1, 2, 3, 4, 5, 6, 7, and 8. So, tama. C8. O, H10. Tatlo. Tatlo, 6 na. Plus 3, 9. Plus 1, 10. So, H10. And then N4. So, 1, 2, 3, 4. Apat na nitrogen. Okay? And then, oxygen, dalawa. We have 1 and 2. So, we have 2 oxygens. So, this is the chemical formula for caffeine. Ito naman yung kanyang structural formula showing yung mga bonds at kung paano sila arranged. Okay? Paano sila nagkakakonekta. And then, this is the ball and stick model for caffeine. Medyo tinilt ko lang yung image para tumugma dito sa image na ginamit natin for the structural formula. Okay, so we're now done with the second learning competency to represent compounds using chemical formulas, structural formulas, and models. Now we move on to the last learning competency that we're going to cover for this video, which is to name compounds given their formula and write their formula given the name of the compound. Okay, so before that, nga pala, bago tayo magtuloy, first we have to determine review lang natin kung paano natin malalaman if a compound is ionic or covalent. Okay, because again, magkaiba yung rules in naming ionic compounds and covalent compounds. So how do we determine if a compound is ionic? And how do we determine if a compound is covalent? Okay, so ito lang para mabilis tayo. So, simple lang, for ionic, kailangan yung una ay or ionic compounds are composed of a metal plus a non-metal. Okay? So, kailangan familiar kayo sa sa mga elements sa periodic table, kung ano yung mga metals at ano yung mga non-metals. Mamaya review natin. Ayan. So, ito yung mga metals natin. These are the metals except for for hydrogen. Itong mga to, ayan. Mga yan. Kasama to, ayan. Boron, sinasama na natin minsan yan. Though, metalloid talaga siya, pero minsan sinasama na natin for metals. Okay? So, these are the metals. O, wag na natin sama. Ayan. Pero kasi may kumbaga sa mga examples, mas kino-consider siya as metal. Pero again, metalloid to. Kasi ang metalloid, they have both characteristics of metals and non-metals. Okay? So, these are the metals. Yan. Ito naman yung mga non-metals. Actually, itong mga nasa baba na to, mga metals din yung mga yan. Okay, metals. Pero ito yung mga non-metals lang natin. Okay? Yung mga hindi natin kinover. Maliban dito sa mga light blue or turquoise, whatever. Basta may pagka-blue. Yan yung kasi yung mga metalloids. Itong mga to, ayan. So, ayan. Yan. Yung mga yan ay mga non-metals. Napaka-konti lang ng mga non-metals natin. Okay, balik tayo. So again, ionic compounds are made up of metal and the non-metal, while covalent compounds are made up of 2 or more non-metals. Ayan. So again pag ionic, may metal at saka non-metal. Pero pag covalent, 2 or more non-metals ang magkasama. Okay? So, eto sa ionic compounds, we have 3 set of rules kasi may iba't ibang types sa mga ionic compounds eh. Yung una, ito yung metals with ionic compounds with metals that have fixed oxidation numbers. Tapos yung isa, yung ionic compounds with polyatomic ions. At yung pangatlo, yung ionic compounds with metals that have variable oxidation numbers. So, ito muna tayo sa merong fixed oxidation numbers ng metals. So ionic compounds with metals that have fixed oxidation numbers. So in naming ionic compounds with metals that have fixed oxidation numbers, first we write the name of the metal, followed by the name of the non-metal ending with IDE. So halimbawa, we have NaCl. Okay? So ang gagawin natin, papangalanan muna natin yung metal which is Na. Again, ginagawa talaga natin nasa left side yung metal. Kasi ang metal, ang charge talaga niya ay positive. While yung non-metal, ito yung negative. Kaya nasa right side siya. Okay, so una pangalanan natin yung metal. Ano ba yung element na Na? It's sodium. Followed by the name of the non-metal. Ang non-metal natin is chlorine. But we change the ending na INE into IDE. So magiging chloride na. Okay, sodium chloride. Okay? So, ito. Kailangan maging familiar din kayo dito. I-memorize ninyo yung mga elements by group. So, ito kasi yung mga metals na mayroong fixed oxidation number. Itong grupo na ito, na nasa group 1A, so group 1A, tsaka sa 2A, group 2A, may mga fixed oxidation numbers ang mga yan. Ito ay lahat sila, maliban sa hydrogen, it's positive 1. And all elements in group 2A ay positive 2. So ano-ano yung mga elements sa group 1A? We have lithium, sodium, potassium, rubidium, cesium, and francium. All of them, they have positive 1 charge or oxidation number. While the elements in group 2A, we have beryllium, magnesium, calcium, strontium, barium, and radium. They all have a charge of positive 2. So, kailangan kabissaduhin nyo sila by group. Okay, para once na nakita ninyo, okay, halimbawa nakita ninyo ay potassium. Okay, nasa group 1A yan. So, ang charge yan ay positive 1. Okay, ang calcium, nakita mo sa chemical formula, ano kaya ang charge ng calcium? So, ang calcium ay nasa group 2A, so its charge is positive 2. May iba pang mga metals dito na may mga fixed oxidation number. Halimbawa, itong aluminum, it's always positive 3. Itong boron nga is actually a metalloid, pero may pagka-metallic pa rin ng property niya, kaya madalas din siya nagagamit as an ionic compound. So this is positive 3 rin. And zinc is positive 2. And silver is also a metal with fixed oxidation number. Positive 1 naman yan. Okay? So, yan yung mga kailangan nyo tandaan. Yung mga nasa group 1A, group 2A, yung boron, aluminum, zinc, and silver. Itong, alam ko yung cadmium, positive 2 rin yan. Okay? Tapos yung iba dyan, yung mga metals, iba pa mga metals din, yun yung mga paiba-iba na. O marami na silang mga oxidation numbers. May positive 1, may positive 2, may positive 3, positive 5, ganun. Pero itong mga to, yung mga minention ko kanina, iisa lang yung kanilang mga charges. O fixed yung kanilang oxidation number, which is, yan, yung mga given natin. 1, 2, tas 3 naman to, and so on. So, let's have some examples. So, halimbawa, ito. What is the name of this ionic compound? So, CsCl. Okay? So, anong element ba tong Cs? Okay? So, this is cesium. Well, this is, Cl is chlorine. Pero yung chlorine nga natin, papalitan natin yung ending niya. Instead of I-N-E, gagawin nating I-D-E. So therefore, the name of this compound is cesium chloride. Let's have another example. MgS. So ano ang Mg? This is magnesium, while this one is, S is sulfur. So ano magiging ending nito? Yung sulfur. Ayan, sulfur. Anong ending niya? So hindi mo ikakabit yung IDE dyan ha, hindi ganon. So change mo itong or into IDE. So magiging magnesium sulfide. Okay, isa pa nga pala, hindi kasi natin naibigay na example dito. Halimbawa, we have MgO. Magnesium din yan. Magnesium yan. Eh, paano naman ito? It's oxygen. Sa kaso naman na ito, ang papalitan natin ay itong YgN. So, siya ay magiging oxide. Okay? So, yan. Let's have another example. We have, okay, Ca. Ca is calcium, while Br is bromine. Pero yung yung INE ng bromine, papalitan natin ng IDE, so it becomes calcium bromide. Okay? Next. Okay, barium. Itong Ba. While this one is iodine, papalitan uli natin yung ending niya to IDE. So therefore, the name of this compound is barium iodide. Okay, meron pa ba? Ito naman, another set of rules for a different type of ionic compound. This one is an ionic compound with polyatomic ions. Okay, so in naming ionic compounds with polyatomic ions, first we write the name of the metal, followed by the name of the polyatomic ions. Pagsasamahin mo lang sila, ganun lang. Wala ka nang papalitan na suffix. Okay? Halimbawa, ito, we have Na2SO4. So, Na is sodium, while SO4 is sulfate. Ganun lang. Ang problema lang dito, you have to memorize a lot of polyatomic ions. Kailangan nyo talaga magkabisado. Okay? So, halimbawa, ito. Ano yung metal natin? Our metal here is K. So, this is potassium. How about yung ayan, naklik tuloy. How about itong BrO3? Ayan, yan yung kailangan nyo makabisado. Okay, so this polyatomic ion is called bromate. So, papagsamahin lang natin mga pangalan nila. This is, so, potassium bromate. Let's have another example. We have this chemical formula. So, anong metal to? This is calcium. Calcium. How about SiO4? Anong polyatomic yan? Polyatomic ion yan. So, that is sulfate. Ito na yun. Silicate pala. Sulfate. Si. So, it's silicate. So, it's calcium silicate. Another example. Okay. So, ayan. Tulad nga na sinabi ko, minsan tinitreat natin siya. Kahit na metalloid yan, tinitreat din natin minsan siya as metal. Okay. So, this is boron. Okay. How about this? Anong polyatomic ion yan? So, this is nitrate. So, it's boron nitrate. Okay. Another example. Okay. Ano yung metal natin? Our metal is sodium. How about this one? Di ba, SO4, yun yung sulfate. Paano to may hydrogen pa? Hindi yan, sulfate. So, ang pangalan yan ay, may ibang tawag tong kapag merong H yung SO4, we call that as bisulfate. Pero, pwede rin natin siya tawagin as hydrogen sulfate. So, the name of this compound is sodium bisulfate or sodium hydrogen sulfate. Okay? Ano pa ba? Ayan, last, we have sodium. Okay? Followed by this polyatomic ion. So, anong polyatomic ion yan? That is cyanide. So, this compound is sodium cyanide. Napaka-potent na lason yan. Mga ilang segundo lang, pwede ka nang mamatay dyan. Wala pang 1 minuto, mamamatay ka na. Kapag marami-rami yung na-ingest mo na sodium cyanide. Okay, the last step or set of steps in naming ionic compounds is for ionic compounds with metals that have variable oxidation number. So, pag sinabi natin variable oxidation number, hindi isa lang yung oxidation number niya. Pwedeng dalawa, pwedeng tatlo. Pero sa mga cases natin dito, yung tigdadalawa lang yung gagamitin natin. Okay? So, halimbawa, sa chromium. Ang chromium natin, meron tayong positive 2 at saka merong positive 3. So, paano mo papangalanan yun? Paano mo madi-differentiate? Kung susundan natin yung unang rule na papangalanan mo lang yung metal, hindi natin sila ma-differentiate kung sinabi mo lang chromium. Anong chromium yun? Positive 2 or positive 3? So, we have to identify. That's why we have a different set of rules for these metals that have variable oxidation number. So, meron tayong dalawang steps dyan or dalawang set of rules. We have traditional and the stock method. For the traditional method, first we write the traditional name of the metal depending on the charge of the metal, and then we write the name of the non-metal ending with IDE or polyatomic ion. So, papagsamahin natin yung unang dalawang na-discuss natin na set of rules. So again, you write the name of the traditional name of the metal. Ito yung mga yon. Kung Cr2, chromous, Cr3 positive, chromic. Manganese 2 positive, manganese. Manganese 3 positive, manganic. Okay, so ganun. So, followed by the name of the non-metal ending with IDE or kung ang kasama naman niya ay polyatomic ion, papangalanan mo yung polyatomic ion. So, let's have some examples. First one is this. Okay? So, dito nga lang, kailangan nating gumamit ng reverse, what we call as the reverse crisscross method. For the reverse crisscross method, yung subscript ng isang element ang magiging charge ng kabilang element. Okay? Pero take note again, positive yung nasa left side at negative yung nasa right side. So, halimbawa, ito, arsenic, ang subscript niya ay 2. Pag nag-reverse crisscross tayo, kasi meron din tayong crisscross method talaga. Mamaya may encounter natin. So, ito ay magiging charge ngayon ni oxygen. So, it becomes, dahil nasa right side nga siya, this becomes negative 2. While oxygen, okay, i-reverse crisscross natin siya. So, this becomes the charge of arsenic. So, it's positive 5. Ito, take note nga pala, oxygen is always negative 2. Para sa lahat ng mga ibibigay ko mga examples. Hindi ako magbibigay ng mga peroxide or superoxide para hindi kayo malito. Basta, every time na makaka-encounter kayo ng mga examples na ibibigay ko, oxygen is always negative 2. Okay? Huwag nang i-overcomplicate. Huwag nang mag-isip kung yung oxygen na yan ay peroxide ba yan or superoxide. Huwag na mag-isip muna. Hindi ko kayo masyadong pahihirapan. Basta kapag oxygen, it's always negative 2 for my examples. Pero syempre sa higher chem, o kaya sa chem sa college, pwede kayo maka-encounter ng peroxide at saka ng superoxide na iba yung charge ng oxygen. Okay, now, since okay naman, wala na tayong problema sa charge ng oxygen, negative 2 talaga siya. So, therefore, the charge of arsenic is positive 5. And arsenic positive 5 has a traditional name of arsenic. Therefore, the name of this compound is arsenic. Okay, ito yung traditional name, arsenic. And oxygen yung non-metal. So, it's oxide. So, it's, wala nakalagay. So, ako magsusulat. So, it's arsenic oxide. Okay? Palitan nga natin yung kulay ng aking pen. Ano ba? Lighter yellow. Ayan. So, next. How about this one? Ito. So, CR, CL2. O, ano yung subscript ng CR? Wala namang nakalagay. So, again, automatic, that's 1. Okay? So, i-reverse crisscross natin yan. Yung subscript na ni chromium ay magiging charge ni chlorine. So, it becomes negative 1 kasi nga negative yung palagi yung nasa left side o nasa right side ng formula. And yung 2 naman ni chlorine becomes the charge of chromium. So, it's positive 2. Okay? So, si chlorine talagang negative 1 yan. Yung family niya ng elements ng chlorine. Balikan nga natin saglit. Yung periodic table natin. Nakalimutan ko i-discuss kanina. Ayan. So, itong family na ito nila, fluorine, chlorine, bromine, iodine, and astatine, kapag nasa right side sila ng formula, sila ay palaging negative 1. Si oxygen, sulfur, and selenium, pag nasa right side din sila ng formula, negative 2. Okay? Ganon din si nitrogen and phosphorus, negative 3 naman, kapag nasa right side. Pero pag nasa left side sila ng formula, doon na nag-iiba yung kanilang mga charges. Positive sila, syempre. Pag nasa left side. Okay? So, tandaan nyo na lang yun. So, balik tayo dun sa example natin kanina. Ayan. Ayan. So, since positive 2, itong charge ni chromium, so its traditional name is chromos. Therefore, the traditional name of CrCl2 is chromos chloride. Okay? Now, let's say for example, ang naibigay sa inyo ay CrCl3. O, ano naman yan? Paano naman yan? So again, pag pinag-criss-cross mo kasi yan, so this becomes positive 3 and chlorine becomes negative 1. So, dahil positive 3 si chromium, magiging chromic. So, therefore, ito naman, ang magiging name naman nito ay chromic chloride. Okay? Next, another example, we have HgO. Okay, dahil walang nakalagay, automatic sila ay 1. Pero ito, pag nag-reverse crisscross ka kasi, yung 1 na yan ay magiging charge ni oxygen. So, balik tayo. Ayan. So, this becomes negative 1. Diba, si oxygen ay negative 2? Bakit dito negative 1? So, ito, kapag crisscross din natin to, nag-reverse crisscross din tayo, mercury becomes positive 1. Ang problema kasi natin, bakit si oxygen naging negative 1? Di ba sabi ko nga, normally si oxygen ay negative 2. Ano to, superoxide ba yan? Or peroxide? Hindi. Sabi ko nga sa inyo, hindi ako magbibigay ng peroxide o kaya superoxide eh. So, oxide lang talaga yan. So, bakit siya naging negative 1? Bakit nag-positive dito? It's positive 1. Ayan. So, anong nangyari, most likely, is nagkaroon ng ng simplification. Yung nilowest term natin sila. So, para makorek natin ito, ang gagawin natin, we are going to multiply both charges by 2. Okay? So, this becomes negative 2, and this becomes positive 2. Ano ba yan? Palagi akong positive 3. Ayan, so it's positive 2. Okay, so hindi na ito yung gagamitin natin. Ngayon, tama na. Oxygen is negative 2. At ngayon, nalaman na natin kung ano talaga yung charge ni mercury. So, the charge of mercury is positive 2. And positive 2 na mercury is called mercury. So, therefore, the name of this compound is mercuric oxide. So, again, baka dito na kayo malito. Kasi nga, nung nag-criss-cross tayo, kasi wala nakalagay na na subscript dito, automatic 1. Pag nag-reverse crisscross tayo, ang lalabas na charge ni oxygen is -1, which is hindi nga pwede kasi ang ginamit natin dito ay oxide lang talaga. Okay? So, to correct this, we are going to multiply both charges of these atoms by 2 para tumama yung charge natin. So, oxygen now becomes -2. Dahil doon, nag-adjust din yung charge nung metal natin. So, it's now +2. Okay, ngayon tama na yung charge ng oxygen natin at ito na talaga yung lalabas sa charge nung metal natin which is mercury. Mamaya magbibigay pa uli ako ng example. Okay, ito, good example rin ito. We have copper and this polyatomic ion na carbonate, yung CO3. Okay, so automatic, dahil walang nakalagay dyan, this is 1. Pag nag-reverse crisscross tayo, saan natin siya i-reverse crisscross? Sa carbon o sa oxygen? No, hindi. Yan ay actually sa buong polyatomic ion na yan. So, pinaparenthesis natin siya. Okay? So, the charge of this polyatomic ion is -1. Ano naman yung i-cross, natin, i-reverse crisscross natin doon? Ito, yung 1 ba ni carbon o yung 3 ni oxygen? Actually, neither of the two. Yung subscript ng buong polyatomic ion, which is 1. Yun nandito sa labas. Pag ni-reverse crisscross natin yan, then, the oxidation number or the charge of copper is +1. Unfortunately, kung kabisado na ninyo yung mga polyatomic ions, okay, pati yung mga charges nila, carbonate is not -1. Carbonate is actually is -2. So, paano natin i-correct yan? So, to correct this, again, just like what we did earlier, okay, we are going to multiply both charges by 2. So, this becomes -2, which is the correct charge for carbonate. And this becomes +2, which is now also the correct charge for copper. And +2 na copper is cupric. Therefore, the name of this compound is cupric carbonate. So, mahalaga talaga na kabisado ninyo yung mga polyatomic ions din. Katulad ng example nito, alam ninyo na ito ay isang polyatomic ion, tapos alam din ninyo kung ano yung charge nila. Kasi kung it turns out na ang lumabas -1, nag-settle na kagad kayo doon, tapos pinangalanan ninyo. Lalabas yan na ito +1, so magiging cuprous yan. Pero mali. Kasi nga, si carbonate is -2. So, we have to correct by multiplying their charges by 2 para maging -2 si carbonate. Tama na yung charge natin for carbonate. And the charge for copper is now +2, which is cupric. So, kaya ito yung magiging tamang pangalan natin for this compound. Okay. Dito na, tapos na tayo sa traditional method. Now, let's move on to stock method. For stock method, actually mas madali ito sa traditional method Ang gagawin natin is, we write the English name of the metal followed by its oxidation state written in Roman numeral enclosed in parentheses. And then you write the name of the non-metal ending with IDE or the name of the polyatomic ion. Halimbawa nito, yung huli natin ginawa kanina, this is cupric carbonate, di ba? So, paano natin siya papangalanan using stock method? Dito madali na lang. Kanina, alam na natin na this is +2. Kasi ito nga ay si -2 kaya wala sila mga subscript dyan. So, how do you write the stock name for cupric carbonate? So, first, we write the English name of the metal. What is the English name of Cu? This is copper. Yung pangalan niya sa periodic table natin. Yun yung English name niya. Copper. Pero, we are going to indicate the oxidation state. O kaya yung oxidation state, yun yung charge niya rin Oxidation state niya is +2. Paano natin siya isusulat? In Roman numeral enclosed in parentheses. Okay? So, 2, yan. Tapos, enclose natin sa parentheses. Followed by the name of the non-metal ending with IDE or polyatomic ion. In this case, polyatomic ion. So, it's carbonate. Ang basa dyan ay copper 2 carbonate. Hindi mo nasasabihin na copper, open close parenthesis, 2 carbonate. Hindi ganon. It's copper 2 carbonate. Okay, next. Ayun na pala. Next. How about this one? O, diba? Kanina, 1 yan. 1. Pag criss-cross mo, magiging negative 1, positive 1. Pero hindi nga pwede. So, we multiply them by 2. Kaya magiging negative 2, positive 2 naman ito. So, therefore, this is mercury oxide. Diba? So, in stock method, isulat na natin yung English name niya. Mercuric is mercury. Pero dahil mercuric siya, ang charge niya ay 2. So, you write the Roman numeral 2 beside the English name na mercury, followed by the oxide. So, it's mercury 2 oxide. Okay, next. How about this one? So, again, this is chromous chloride, and chromous is positive 2. So, therefore, sulat lang natin yung pangalan ng metal, which is chromium. Is indicate mo yung charge. Okay, in Roman numeral, in closing parenthesis, therefore, the name of this compound is chromium 2 chloride. Okay? And then, last one, for naming of ionic compounds, pero hindi pa tayo matatapos dito. May iba pa tayong papangalanan at aaralin. So, this is arsenic oxide. And the arsenic oxide, ang charge niya ay positive 5. So, therefore, if we write this in stock method, yung Roman numeral natin ay 5. So, therefore, this is arsenic 5 oxide. So, that's how you name ionic compounds. Yung may metal with variable oxidation number, metal with fixed oxidation number, and ionic compound with polyatomic ions. Okay. Now, how about covalent compounds? Paano magpangalan? Ito, isa lang yung rule. Or dalawa pala. Ito. So, in naming ionic compounds whose positive ion or positive atom contains one atom, you write the name of the positive atom followed by the name of the negative atom with the correct prefix indicating the number of the negative atoms. Okay? So, ito yung mga yung minimension dito na prefixes na gagamitin natin ay ito. So, kung isa lang yung atom, we use mono as prefix. Pag dalawa, di. Pag tatlo, tri. Apat, tetra. 5, penta. 6, hexa. 7, hepta. 8, octa. 9, nona. And 10, deca. Okay? So, ito yung kakabit natin dun sa negative atom o yung nasa right side ng formula ng covalent compounds. But, if the positive atom contains more than one atoms, okay, you will also have to attach the appropriate prefix kapag more than one siya. Pero kapag isa lang, yung atom na nasa left side ng formula natin, then, no need to write a prefix, yung prefix na mono. Okay? So, halimbawa, ganito. Ito, napaka-common na compound nito. So, dahil nag-iisa lang yan, wala tayong ilalagay na prefix. Pero dito, dalawa yan. So, indicate natin yung number ng atoms by attaching a prefix to the name of this element. Pero, gagamitin pa rin natin yung IDE. So, this is still oxide. Okay? Pero mag-attach tayo ng prefix na di kasi dalawa yung oxygen natin. So, therefore, this is carbon dioxide. Dalawa yung oxide eh. So, carbon, oxide, pero dalawa. So, it's carbon dioxide. How about this one? Oh. So, isa lang yung natin, yung oxygen. Ito, wala namang problema dahil pag isa nga lang, hindi natin kakabitan ng prefix itong unang element. Sa pangalawang element tayo, mas mag-focus. So, nag-iisa lang yan. So, therefore, this is, yung prefix na gagamitin is mono. So, the name of this compound is carbon monoxide. Pero, di ba, dapat monooxide siya. Bakit nawala yung isang O? Ina-omit lang natin para mas madaling bigkasin. Kasi anong mas madaling bigkasin? Monooxide o monoxide? Siyempre yung monoxide. Monoxide. Diba? O halimbawa, we have pentaoxide versus pentoxide. O mas madaling bigkasin, pentaoxide or pentoxide? Siyempre ito. Diba? So, ganun din sa iba pa dyan. Tetraoxide, tetroxide, yung mga ganun. Pero yung trioxide, wala namang problema sa pagbigkas eh. Yung iba lang. Yung nag-i-end din sa sa A. Okay? Another example, ayan. SiF4. So, Si is silicon. Diba? While F is fluorine. Pero dahil apat yan, ang prefix na gagamitin natin ay ito, tetra. So, therefore, the name of this compound is silicon tetrafluoride. Okay, another. We have, what element is this? C lang. C. This is carbon. While Br is bromine. Apat yung bromine. So, tetra uli ang gagamitin. So, therefore, this is carbon tetrabromide. Okay. How about this one? Ayan. In this case, dalawa yung positive atom natin. O yung nasa left side ng formula natin. Now, in this case, magkakabit na tayo ng prefix which is, dahil dalawa yan, di. Tapos yung fluorine naman natin, 6. So, 6. So, the name of this compound is, ayan, dinitrogen hexafluoride. Okay? Ayan, naglagay tayo ng prefix na di kasi dalawa na siya. Okay? Pero pag isa lang, hindi ka magkakabit ng kahit na ng prefix. Okay, another example, we have P2S3. P is phosphorus, dalawa, so di. And S3, S is sulfur, tatlo, so tri. So therefore, the name of this compound is diphosphorus trisulfide. Okay. So that's it for naming covalent compounds. So, tandaan lang yung mga rules na yan. And then, last lesson na lang natin, ito, how do we write chemical formulas given the name naman. Kanina, formula yung binigay, tapos papangalanan natin. Ngayon naman, yung pangalan ng chemical, tapos susulat natin yung formula. So, ito yung mga steps. Una, you write the name of the symbols. So, halimbawa, potassium is K, sulfide is S from sulfur. Calcium is Ca, nitride is N. Aluminum is Al, sulfate, polyatomic ion, so this is SO4. Barium is Ba, while oxygen or oxide is O, oxygen. Ayun. Now, second step is to determine the charges. So, positive 1, si potassium, and sulfur is negative 2 or 2 negative. Calcium is 2 positive, while nitride is 3 negative. Aluminum is 3 positive, while sulfate is 2 negative. Barium is 2 positive, and oxide is 2 negative. Okay. So, the third one is to perform the crisscross method. Ayan, kanina reverse crisscross eh. Kasi meron tayong crisscross method. So, where the charge of an element becomes the subscript naman of the other atom. Okay, place a parenthesis for multiple polyatomic ions. Okay? Or multiple atoms or polyatomic ions. Dapat pala hindi nakasama yan. Okay. So, pag nag-crisscross method tayo, di ba may 1 yan? Okay. So, ito yung magiging subscript ngayon ni sulfur. So, 1 na siya. Itong 2 naman ni sulfur, magiging subscript naman ngayon ni potassium. Therefore, the chemical formula for potassium sulfide is K2S. Hindi na natin lalagay yung 1. Automatic na yon. Okay, next. Calcium. Yung charge niya na positive 2, magiging subscript ni nitrogen. Okay. So, it's 2. While yung 3, negative 3 naman ni nitrogen, becomes the subscript of calcium. So, it's 3. Therefore, The chemical formula for calcium nitride is Ca3N2. Okay. Now, for aluminum sulfate, ito. Ang problema, itong si aluminum positive 3 siya, di ba? Pero saan siya mapupunta? Saan siya magiging subscript? Kay S o kaya kay O? Imumultiply ba natin yan dito sa sa 4? Actually, ganito. Ang gagawin natin, pag ganyan, na more than 1 yung magiging subscript nung sa kabila, ipaparenthesis na natin sila. Okay? Kasi yan na yung magiging subscript niya. So, it's 3. Tapos yung 2 naman na sulfate, yan yung magiging subscript ni aluminum. Therefore, the chemical formula for aluminum sulfate is Al2 and then open close parenthesis SO4 3. Okay? Kasi yung 3 na to, para to sa kabuuan ng SO4 eh. Para sa sulfur yan at saka sa oxygen pareho. Parang distributive property. So, ibig na isulat natin na S3O12, ganito na lang. Okay? SO4 3. Ibig sabihin, tatlong sulfate ions yung nakapalibot sa dalawang aluminum. Okay? Now, for the last one, for barium oxide, mapapansin natin, ano sila? Multiple ng 2. Okay? 2, positive 2, tsaka 2 negative. So, pwede natin silang i-lowest form. So, ito ay magiging, pwede natin silang i-divide by 2. So, this becomes positive 1 and this becomes negative 1. Ay, ano ba yan? Mali ba yung sinulat sa sinabi? So, negative 1. So, pag cross natin sila ngayon, okay, it's barium 1 and oxygen 1. And dahil 1 nga yan, hindi na natin sila kailangan isulat pa. So, therefore, the chemical formula for barium oxide is BaO. Okay, kasi again, the lowest term na natin yung kanilang mga charges. So, may example ba tayo? Ayan, halimbawa. So, we have strontium fluoride. Okay? Sr is 2 positive, while fluoride is negative. Pag pinag-criss-cross natin sila, kalalabasan ay, ako pala magsusulat. Kalalabasan ay Sr, okay? Pag criss-cross natin, ayan. So, magkakaroon tayo ngayon ng 2 dito, 1. So, automatic din tayo magsusulat dyan. So, it's SrF2. Another example, sodium chloride. So, it's Na na positive and Cl na negative. Pag pinag-criss-cross natin, tig-1 lang ang kalalabasan. So, it's NaCl. Another example, ferrous sulfate. Pag ferrous, ano ba yon? Traditional name ng Fe2 positive. Tapos, ang sulfate naman ay SO4. Ang charge niya ay negative 2. Since pareho silang divisible by 2, i-lowest term na natin sila. So, it's positive 1 and negative 1. So, dahil 1 yan pareho, hindi na natin sila ipapakita dyan. So, it's FeSO4. Okay? Ferrous sulfate. Ito yung gamot ng mga anemic. Okay? Paano kung ferric sulfate? Ferric sulfate. Kapag na-expire na yung yung ferrous sulfate mo, okay, magiging ferric sulfate na siya. Lasang kalawang. At pag ininom mo yan, mangangasim yung sikmura mo kasi ito ay acidic yan eh. Magkukos para maging acidic yung sikmura mo. Okay, so ferric is Fe3 positive, while sulfate is SO4 negative 2 or 2 negative. O paano yan? So, pag pinag-criss-cross natin, diba? Nagiging 2 ito. Ito naman ay 3. Pero, i-multiply natin siya sa buong polyatomic ion. So, therefore, for ferric sulfate, it's Fe2, open close parenthesis, SO4, 3. Okay? Another example, we have iron oxide. Ito yung kalawang o rust. Chemical formula for rust. Okay, so iron is, sinabi na dyan, it's positive 3. While oxygen is negative 2. So, pag pinag-criss-cross mo, the formula is Fe2O3. Yan na ba yan? Okay, last. Ito. Now, if you can see, as you can see, we have prefixes here. So, therefore, dahil may prefixes siya, this is a covalent compound. At dahil may prefixes na tayo, sinasabi na kagad dyan kung ilan yung atoms na present sa compound. So, kailangan ba natin mag-criss-cross dyan? Hindi na. Susulat mo na ng diretso kasi sinasabi na nga kung ilan eh. So, dihydrogen means dalawang hydrogen at monooxide or monoxide. So, isa. Ayan. So, this is the name of water. Yung talagang technical name niya or IUPAC name kung tawagin nga sa chemistry. It's dihydrogen monoxide. Yan yung ibang pangalan ng water. Okay, so we're now done with the 3 learning competencies. Now, yung last learning competency, i-include ko na dun sa next video lesson natin. Kasi yun din yung papanoorin pa ng ibang mga kaklase ninyo na naka-attend sa online class namin noong nakaraan kasi hindi na talaga na-cover yung last learning competency. Sobra-sobra na talaga ako sa time. Itong video nga natin, nasa 1 hour and 16 minutes na eh. Sobrang haba kasi talaga ng coverage ng Module 2. Okay, so that's it. Thank you for listening. Sana matandaan ninyo lahat ng mga inaral natin dito. Bye guys!